So what we want to do today is pipes and cisterns. Now, if you've already done the chapter men and work, right? Pipes and cisterns is essentially the same chapter with a few naming differences, right? So if you haven't done men and work, let's quickly revise what we did in men and work, right? We had the following rules. One was that time cannot be added or subtracted, and only rate could be added and subtracted, right? When we did men and work, we assumed that the people in the question were building a wall, right? So for example, we had A can take 5 hours to do a piece of work and B can take 4 hours to do a piece of work. How much time would they take to finish the entire? Would they take to do the piece of work together? Yes. What would we do over there? We would assume the number of bricks that they are building. That is, they have a wall. The number of bricks that they are building is the LCM of the times which are given. That is the LCM of 4 and 5. The same thing we will do over here. The questions over here are essentially that there is a pipe. Okay, it takes 5 hours to fill a tank. Yes, there is pipe A. It takes 5 hours to fill a tank. A takes 5 hours to fill a tank. There is a pipe B which takes 4 hours to fill the same tank. How much time will it take for A and B to fill the same tank if they are both open at the same time? Right? Now if they are both open at the same time, remember I have mentioned time cannot be added or subtracted. Yes, you cannot just say 5 plus 4, 9 hours, because obviously it's going to take less time. It's going to take more time to fill a tank if 2 pipes are open. Yes? Okay, so what do we do? First step, we assume the tank capacity, right, is the LCM of the time given. So what is the capacity of the tank? LCM of 5 and 4, which is what? 20 liters. The capacity of the tank is 20 liters, right? Okay. Then let's find out at what rate does A fill the tank on its own. Rate of A is nothing but the total capacity upon the total time taken to fill the tank. What is the total capacity? 20. Time taken is 5. So the rate is 4 liters per hour. Similarly, rate of B is 20 upon 4, which is 5 liters per hour. Yes? So essentially A fills it at 4 liters per hour and B fills it at 5 liters per hour. So when they are both filling the tank together, the rate will be what? It will get added. Yes or no? So the rate is what? 9 liters per hour. Yes? Now together they are filling 9 liters per hour. So it is 9 liters in 1 hour. How many liters do they have to fill? 20 liters. So cross multiplication, 9x is equal to 20. Therefore x is equal to 20 upon 9 hours. Yes? You may have realized it's exactly similar to how we did men and work. Right? Okay. So let's look at another question. Okay, so now in this question we had 2 pipes which were opened together into a tank. Right? Now what if we have 1 pipe which is filling the tank, say A, and 1 pipe which is emptying the tank. Right? Now tell me one thing, visualize this. In what scenario will the water in the tank go up? In which scenario will the water in the tank go up? Only when the rate of A is greater than the rate of B will the water in the tank go up. Yes or no? right? Imagine filling a bucket of water, right? And there's a small hole and water coming out of it. The water is still going to rise in the bucket. Yes? Now imagine if you're putting little water into it and there's a huge hole. The water is moving out really fast. Will the water level rise or water level drop? The water level will drop because rate of B is greater than rate of A. Yes? Okay. Yes? Right? Okay. Fine. So we have a question which states that a pipe can fill a tank in 15 hours. So this pipe can fill a tank in 15 hours, right? Due to a leak in the bottom, it is filled in 20 hours. So this is the leak in the bottom. The time it takes to fill totally is 20 hours. If the tank is full, how much time will it take? How much time will the leak take to empty it? Okay, right? Fine. Now we need to find how much time will this on its own take to finish and completely empty the tank over here. Right? Okay. So what do we do over here? Right? You have 15. So first step again is assume tank capacity. What is the capacity of the tank? LCM of 15 and 20. Yes? 15 and 20. 2 15s are, 2 10s are, 2 15s are, 5s are, 3 5s are 5. Right? 5 into 2 is 10, 60. So 60 liters is the capacity of the tank. Yes? Okay. Let's find the rate then. The rate of A is 60 upon 15, which is 4 liters per hour. Yes? Now, the effective rate of this, so total rate over here is 60 upon 20, which is what? 3 liters per hour. Right? Now, this is the rate when there is a pipe inside and there is a leakage. Yes? So if there is a leakage, what does this represent? Doesn't this represent rate of A minus rate of B? Right? So this is filling the tank and this is letting go of some water from the tank. Yes? So this A is filling the tank, B is a small leakage which is emptying the tank. Right? So you have 4 liters per hour is equal to, you have 3 liters per hour, which is the total rate, is 4 minus rate of B. Therefore, rate of B is 1 liter per hour. Yes? Now this is the individual rate of B. What have we asked? How much time will B take to empty the full tank? Right? So what is the capacity of a full tank? 60 liters. It empties at a rate of 1 liter per hour. So it empties at a rate of 1 liter per hour. So how much time will it take to empty 60 liters? So you have X is equal to 60 hours. Did you get it? The concept is essentially the same as men work. Right? There's nothing different. You just need to use capacity over here is the LCM of times given. Right? Okay. Please solve the 5 solved examples on page 156 and 157 and solve 15 questions on the exercise on page 157 and 158.